All right. So multi-step equations. Like I said earlier, we did one step, we did 2 steps. So we're going to have at least how many steps on this? 3 steps. At least 3. Could have 4. I don't know. It depends on the problem. So let's just start with number 1. I'm not going to do any pre-problems or anything like that. Let's just start with number 1. So you should be, well, you already have the worksheet, so you don't have to write this part down because it's already in front of you. But let's just, it's not 16, sorry. 6x. Did I write that down correctly? Yep. All right, so let's take a look. Everything that you have to do on this problem, we've already done. So it's nothing new. Everything is just a compilation of what we've done so far, okay? So let's take a look at it. What do you think would be the first thing you would want to do here? I'll give you a hint. Don't all answer at once. Is it 4 times 6? It's not 4 minus 6. It's what? It's negative 4 minus 6. But it's an x. This is that combining like terms. Remember that worksheet? Okay, combining like terms. So that's what we always do first. All right, at least in this situation. All right, there'll be other situations where you can't combine like terms. You might have to do something else. But in this situation, really, the only thing I want to do is just combine like terms. Because I don't want 2 x's here, do I? I just want, how many? Just 1 x, okay? So I'm not going to do anything to the left side, so I'm just going to keep that negative 20. Now over here, it's negative 4 minus 6. Let's do this up here. Negative 4, without using a calculator. Negative 4 minus 6. What's the rule? You should be able to just do this in your head. Add the opposite, so add the opposite. So what do you get? Is it 10? It's negative 10. It's 10. 4 and 6 is 10. So it's negative 10. But it's not just a negative 10, it's a negative 10 what? X, all right? Because you just keep the term with it, the letter with it. Everybody good with that? This actually is only 2 steps. Why do they call it multi-steps? I guess multi means just more than 1, right? I guess it could mean 2. So we got to get x by itself now. So how do I get x by itself? What is that 10? What is that negative 10 doing to that x? It's multiplying. So how do we get rid of something that's being multiplied? We divide it. We don't just divide it by a 10, we divide it by a what? No, not an x. Do not, listen, this is a common mistake. I've seen this a lot by students. I've seen a lot of people try to divide it by 10x. I don't want to get rid of the x. I just want the x to stay there, right? So what am I trying to get rid of? Not the x, but the what? But the negative 10. All right, so I only divide by negative 10. Do not divide by negative 10x. It's a common thing that students do. It's wrong, but it's common. All right, so just divide by negative 10. So if I do that to the right side, then I come over here and I do it to the left side. So that negative 10 right here and that negative 10 cancels out. I got an x. Now what's this? It's negative divided by negative. So when you multiply or divide, it's going to be positive, and then 20 divided by 10 is 2. If you want to write it like this, x is 2. We good with that? So we haven't really done that before. We combined like terms, right? And we did that one-step equations where you got rid of something like this. It's just a combination of those 2 worksheets that we've already done. All right, now they just kind of put them together in one problem. Let me see what's another good one to do. Let's go to number 7. Well, actually, let's do 5 first. Every once in a while, you're going to come out with something weird, all right? Some weird answer, and this is one of them, I'll tell you right now. There's a few other ones. Let me see. 1, 2, oops, where's my other? Oh, there's only 1 page to this, right? Just goes to 20, yeah. So, yeah, there's 2 other problems. I'm not going to tell you which ones they are, but there are 2 other problems that come out to the same answer as this one. It's a kind of a weird one, all right? So it's 4m minus 4 equals 4m. All right? Now, this is a little different because, let me see. Do I want to do that one first? I tell you what, let's put that one on hold. All right? We'll put that one on hold. Let's do number 3 first, okay, before we do this one. So number 3, let's do number 3. So 8x minus 2 equals negative 9 plus 7x. All right, let's do this one first. Then we'll go to do number 5. Number 5 comes out weird. Number 3 comes out pretty normal. All right? So what's different about this? that we haven't done before? Different. So what about the different sides? X is on what? Two different sides, right? So that's what I want to hear. Okay, so X is on the left side and X is on the right side. Up to this point, X has only been on one side, or whatever the variable is, okay? Would you agree with that? So what do you think I want to do then? I want to take one of the X's and move it where? To one of the other sides. I could move it to the left side. I could move it to the right side. It doesn't matter what side we move it to, all right? So that's the first thing that I want to do. Okay, first I look to see if there's any like terms. Can I combine any like terms here? No, because that has an X, that doesn't. This has an X, that doesn't. So I can't combine any like terms. But what I can do is get one of the X's from one side and move it to the other side. So I could, if I wanted to, get rid of this 8x and move it over here. Or I could take this 7x and move it to the left. I'm going to move the 7x and move it to the left-hand side. Okay? The reason I'm going to do it that way is because when I move this 7x over here to the left-hand side, I still have a positive x. If I move the 8x to the right-hand side, I would get 7x minus 8x, and what's 7 minus 8? That's a negative 1x. Do you want to deal with negatives if you don't have to? No, I wouldn't. Okay, so I would move the 7x over to the left-hand side. So what you have to do is you got to look at the whole entire thing. Don't just look at the x, don't look at the 7, look at the whole entire term. What is that whole entire term doing to that negative 9? It's being what? It's being added, isn't it? Okay, so what I'm going to do, I'm going to subtract the 7x. Now remember, I'm not trying to get the x by itself just yet. All I'm trying to do is take that 7x and move it to the other side. So you have to look at it as one big number. Everybody see that? So I'm not dividing by a 7 to get rid of it. Right? What I'm doing is I'm taking that 7x and I'm moving it to the other side. So I subtract a 7x. So what am I going to have to do to the other side? Subtract a 7x, that's right. So I'm going to, and what am I going to subtract it from? Am I going to subtract it from the 8x or from the minus 2? The 8x, right, because they're like terms, right? So I'm going to put it under the 8x. Everybody see that? I'm going to show you in another problem where you could actually do this in one step. But right now I don't want to confuse you, so those cancel, don't they? 7x minus 7x, yep, cancels out to 0. Now let's bring everything down. What's 8x minus 7x? It's 1x, or just x, right? I could put the 1 in front of it if I wanted to. Don't really need it, though. So I'm just going to write an x. Bring everything else down. What do I get? Minus 2. Bring down the equal sign, and then bring down the negative 9. Okay, now I'm not going to do that because look where the x is. The x is already over on the left-hand side, isn't it? So I don't want to take that 9 and move it over with the x. I want to get rid of the thing that's with the x. All right, so I don't want to get rid of the negative 9. I want to get rid of the negative 2. Everybody see that? Okay, because I want the x to stay there. I just want to get rid of that minus 2. So how do I get rid of a minus 2? I add a 2. And I add a 2 to this side. And what do I get? That cancels. Bring down the x equals, what's negative 9 plus 2? It's negative 7, right? They're different signs, so you subtract, you take the sign of the larger number, and you get negative 7. And that's how we do that. So that's a little different, right, than what you've been doing so far. Okay, getting rid of a 7x and moving it over to the other side. So that was a little different. That's not something that we talked about earlier. But it kind of is, right? It's kind of the same thing, but a little different. Let's go back to number 5, okay? Number 5 is the one that I said is going to come out kind of weird. Let's check this out. I got a 4m on the right side. I got a 4m on the left side. So what do I want to do here? Get the m's on the same side normally, right? Okay, so I could move this 4m over here to the right, or I could take this 4m and move it to the left. What would you rather do? Move this to the left? Okay. So if I subtract a 4m, I do that by subtracting, correct? Again, I'm not trying to get the m by itself right now. I'm just trying to combine the m terms. So I take that whole entire 4m and I move it over to the other side. So I subtract a 4m. Do you see what something weird is? you see this something that's weird? What is it? Right. So what happens here? These cancel out to be a 0, correct? Now, I say cancel out, but I made a big deal when I first started doing this, is you got to know that they add up to 0. So I put the equal sign. So I don't just put a nothing here. What do I put here? A 0, right? What happens to this? 4m minus 4m. That's a 0. But what's 0 minus 4? It's negative 4. So is x equal to negative 4? Is that my answer? Or m, not x. Sorry, I'm used to using x. But no, I don't have m anywhere. Look what happened to my m's. They did what? They all canceled out. So I don't have a variable anymore. So that's the weird thing that happens. And look what I get. I get negative 4 equals 0. Is that true? Does negative 4 equal 0? Of course it doesn't. All right? So what we say is we say that there is no solution for this. So when it comes out weird like this, and you don't have a variable, if your variable's all canceled out, you're going to say no solution. Because there's no number that you could put in for m that's going to make the left side equal to the right side. For example, let's pick any number at all. Pick a small number. Don't pick anything outrageous. Pick a small little number and put it in for m. 6. Okay, so 4 times 6 minus 4, will that equal 4 times 6? Think about that. No, because this is 24 minus 4, which is what? 20. Does 20 equal 24? No, it doesn't. Okay, so 6 doesn't work. I could keep doing this all day long, and there is no number. There's no number I can put in for m that the left side is going to equal the right side. If you think about it, look. If I take a number, right, 4m, and I subtract 4 from it, will I ever be left with what I originally started with, the 4m? No, because what am I doing to that 4m? I'm taking something away from it, which changes the value of it, correct? So if I go 4m minus 4, there's no way that's going to equal what we started with. Do you see that? So I can just look at it without even doing the math, without even doing the algebra, just looking at it right now, I could tell you that there's no solution for this, because there's no way if I take a 4 away from 4m, it's going to equal the 4m, what I started with to begin with. Everybody got that? Okay, enough of that. There's 2 more like that, all right? I'm not going to tell you which ones. I don't want to spoil the fun. But let's do another problem. Let's do number 10. All right, so it's 12. So look at it and think of what do you think the first step is going to be. The first step is always the one that's probably the hardest for a lot of students. Okay, what do I do first? I'm looking at it, Mr. Hamrick, if I just knew what to do first, then it kind of all falls into place. But sometimes it's hard to see what you do first. Well, first of all, what I do, if I see parentheses, I look to see if there's any like terms. Can I add any like terms in here at all? No. This has an X, this doesn't, so I can't add anything there. Can I add any like terms anywhere else? Nope. That's the first thing I look for, though. I look to see if I can add any like terms. What's the next thing I want to try to do here? I want to try to eliminate those parentheses, right? So how can I get those parentheses? This is something that we've done. We had a whole worksheet on it. And it was called the what? Distributive property. Exactly right. Okay, so remember the distributive property worksheet? So I'm going to take that negative 4 and I'm going to distribute it. I'm going to multiply it by this first one, and then I'm going to multiply it by the second one. Yes, we remember distributive worksheet? Yeah, got a couple people out on me now. So try to stay awake, pay attention. All right, so I didn't do anything to the left side. There's nothing I can do over there. So what am I going to do here? I'm going to take that whole entire negative 4. You got to distribute the negative as well as the 4. Don't forget the negative. Okay, that's part of the 4. Everybody got it? So it's negative 4 times what? Negative 6x. So what's negative 4 times negative 6? Positive what? 24 and then x. All right, because that's got an x with it, so my answer's got to have an x with it. Let's do one more thing. Let's take that negative 4 and multiply it by what? Negative 3. Very good. Now you're getting the hang of it. Negative 4 times negative 3. What's negative 4 times negative 3? It's positive, so I put a what? Plus what? No. Oops. Stupid marker or pen. Plus 12. I know you were. That's why I woke you up. Everybody see that? So that was distributive property. We had a whole lesson. We've gone over it and all that stuff. So that was one step. So this is actually a 3-step problem. So what are we going to do now? Minus 12, right. So this should be pretty familiar to you now. All right, so I subtract 12 from both sides. That cancels. What happens here? 12 minus 12. Do they just cancel? No, they do what? They subtract to be what? 0. So there's nothing else on that left side, so I got to put a 0. Does that mean this is one of those weird problems where it comes out to no solution? No, not necessarily, just because you have a 0. Those canceled, they added up to 0, so what do I bring down? 24x. One more step. How do I get the x by itself? Divide by 24, that's right, divide by 24. Now we had a big long talk about this yesterday. So x equals, what's 0 divided by 24? Is that an error on the calculator? No, it's a 0. That's right, 0 divided by 24 is 0, and that's your answer. What do you think? Yeah. Great response. If it was 24 divided by 0, be an error, right? You would still say no solution, okay? But this one's not. It's 0 divided by 24. When are we out of here? 10:30? Ugh, I don't know if I have enough time to do this. Well, let's take a look. Let's just take a look at them. Look at 18. What's your first steps on 18? Give me a good math word. Give me one good math word. Distribute. Very good. That's it. So you're going to distribute the -3 through that first parentheses. And then you're also going to distribute something else, though, aren't you? What else are you going to distribute? The 4. Right. Everybody see that? And then you just work out the normal way. All right. What about 20? What are you going to distribute there? 5. The -5 in the first one. And then the what? +5 in the second one. And then you always look to see if there's like terms. Right? So some of these might be 4 steps. They could be 5 steps. But every single one of these steps we have done before. All right, it's just putting it all together. Okay? All right, get that finished. There's only 20 of them this time, okay? And I've done 4 of them for you. So get those finished. They'll be due tomorrow. This is our last worksheet. Okay, next week, well, we'll probably have a test on this, okay? Not sure exactly what day. Probably early next week. Probably Tuesday would be my guess. Probably Tuesday of next week we'll have a test on this. We'll do corrections Thursday. So when are we going to start geometry again? Probably Thursday of next week. Okay? All right. That's it.